Excuse me, sir. Sir, unmute, please.
I am.
Thank you, sir.
Do we have any online student?
Not yet.
Okay, so my name is Uday. And I was told that I have to ask you which topic you want me to start with. So those 3 chapters I believe are completed. Shall I proceed with chapter 4?
Yes.
Right. Okay. So begin with that. So chapter 4. What's the name? Pressure.
Pressure. Atmospheric pressure. Pressure.
Fluids. And atmospheric pressure. Okay, so we're going to learn about pressure and fluids. So let's begin by understanding what is fluid. Any idea what is fluid?
Anything that has the ability to flow, like gas.
Correct. So anything that can flow. Anything. That can flow is called fluid. Okay, so like she said, example, gases and liquids. Right? So gases as in air. Air is also fluid, right? Liquid also flows. So this is fluid. So what we are going to learn about is pressure inside fluid. For example, if you have a beaker full of water, right? So we are supposed to find out what is the pressure here. Let's say this is A. These are different points or different levels, right?
So much because it's towards the pressure, it will be equal at all directions.
So we'll come to it, right? So we'll understand the nature of pressure, why it is equal in all directions, etc. Yes, and we derive the expression for it. So to understand pressure, we need to understand about a physical quantity called thrust. Okay. So is this chapter taught at your schools?
For us,
For
we are
home?
doing reflection.
Yeah. Okay. So I thought so.
Yes, that's the reason I will ask.
Just keep it. So that's okay. So what is thrust? Anybody has any idea? It is a. It is perpendicular. It is a perpendicular force. It is a perpendicular force acting on surface. Acting on surface. Okay, so thrust is a force, first of all. What kind of force is that? Perpendicular force, right? So I am standing on this floor. What kind of force am I exerting? Thrust. Okay, my weight is exerting thrust, right? Any force which is perpendicular to the surface, it is called thrust. Okay. So what should be unit of thrust? So example, suppose you have a tabletop and a block is kept, right? So where will be its weight? Downwards. So its weight will be downwards. How much is that? Mass times acceleration due to gravity. That is the weight. Okay. So this is the perpendicular weight exerts thrust. on the tabletop. This is the example of thrust. Okay, because it will always exert perpendicular or normal force. What is the other term for perpendicular? Normal. Clear? So what is the unit for thrust? Same as unit of force. So what are the unit of force? Newton. SI unit is Newton. CGS unit?
Nine.
Gravitational unit?
kg.
Yes, it is kg. So gravitational unit has for SI it is kg and CGS unit is ground force. Clear? So these are all units of force only. This is SI unit. This is your CGS unit. What is the relation between the two? So what is Newton? Newton is kg meter per second square, right? Newton is kg meter per second square. What is the relation between SI and CGS? Since 1 Newton is equal to 1 kg meter per second square. So therefore it is 1, this is 1000 grams into 100 centimeters. Okay, so per second square. So you have how many? 10 raised to 5 gram centimeter per second square. What is gram centimeter per second square? 9. This is gram centimeter per second square. So this is equal to 10 raised to 5. Understood? So this is the relation between Newton and what is KGF equal to? What is the relation between KGF and Newton? So what is KGF? It is the force exerted by Earth on an object of 1 kilogram. Okay. So what is the force? Mass times gravity. So you multiply value of gravity in this. So 1 kgf is equal to almost 9.8 Newton. You just have to multiply it with the value of gravity. 1 gram force is equal to how much? What is CGS value of gravity? 980. Okay, so it will be 989. All right. So note down. So everybody is like a habit of writing down everything. Right. What is the right say? You spread it, not the way you spread it. Sit inside and spread it. Is it okay? If it is too inconvenient, keep it also. Otherwise, it's scary. It's like. If it is inconvenient, keep it out. No problem. No problem. Everybody is signed. Somebody came late. Everybody signed. Just do it. Read it, all of you?
Yes.
That's right. So have you all understood everything? Can anybody tell me what type of quantity is thrust, scalar or vector? Why? So it is force, right? So it has both magnitude and direction, right? That's a type of vector. Okay. So everybody is right. Let's now start with pressure. Can I erase this?
Yes.
Pressure P. So it is defined as thrust acting per unit area. Thrust acting per unit area. Okay, so focus on the left side of the book. Right, so the pressure P is equal to thrust area. Okay. So, what is it, sir? What is the unit? Yes. Unit is Newton per meter square or Pascal. Okay, it is called Pascal. The full unit name is written like this, small letters. Symbol is PA. Okay. Likewise, it will be dyne per centimeter square for CGS. Okay. So mostly we'll be dealing with SI units are asked for CGS unit. Okay. So most of the time it will be SI units. Right. So there are other units of pressure. Any idea what are other units of pressure? Yes. Now, there is also pressure is, what is atmospheric pressure? How is it measured? That's the instrument, but atmospheric pressure unit is ATM. Okay. So atmospheric pressure is measured in atmospheric pressure. Yeah, I will we'll talk about it. Atmospheric pressure is measured in ATM. ATM is acronym for atmosphere. ATM. So 1 ATM is equal to 1.013 to 10 raised to 5 Pascal. This is the relation between atmospheric pressure and Pascal, unit of pressure. So it's a very large force, right? Almost 1 lakh Newton is acting on us all the time. Any idea what is 1 Newton? If you are holding 1 kg, right? It's 9.8 Newton, like 10 Newton, right? So this is 1 lakh Newton. It's like how many kgs? 1 lakh. 10,000 kgs, right? 10,000 kgs are kept on us from outside. Does it give you an idea how strong we are? Because of the blood pressure. So our heart is pumping blood at that pressure so that we are not able to feel it. Okay, so that's the pressure of atmosphere on Earth. So what is that pressure? So suppose you're standing here. So Earth is enveloped by atmosphere, right? So everywhere around us there is atmosphere. This is almost 300 to 400 kilometers, right? Above us. So all that air is fluid, and fluid exerts pressure, right? So we are surrounded by air all around. So from all sides, okay, there is pressure on us. And that is given as 180, needed for atmospheric pressure. Okay. Now let us derive an expression for pressure due to liquid column. So before that, we were discussing units. What are the other units of pressure? How much is this 1 atmosphere equal to? This is equal to the pressure exerted by 760 millimeter of mercury of Hg. Okay? So here, which is how much? 76 centimeter of Hg or 0.76 liter of Hg. What it means is, suppose you take a glass tube, almost 1 meter long, okay? And if you fill it with mercury, okay, let's say this is 100 centimeter. This is 76 centimeter. So whatever pressure it exerts at the bottom, okay, when I fill mercury, what is it? Mercury. Okay, whatever pressure it exerts over here, this pressure we call 180. Because it is a pressure due to a mercury of column 76 centimeter from ground. Understood? So that pressure we take it as 180. Okay, 180 is equal to that. Right. Then we have bar. Where is bar? Don't use one. Why? What's not there? It's all right. You can use textbook, but is there any hatred or this should be a primary source, the textbook. Okay, volume is good for reading. So I agree with you.
Sheets for what kind of answer?
Right.
Vehicles and all, we would from volume questions and all. Restaurant study,
It's all right.
both are the same.
Both are similar. Volume is a
Little bit volume.
volume is little short.
Yeah, sir.
And sometimes there are typing errors. That's the only thing. So it's a good summary. So for revision purposes, you can refer to it. But textbook is, of course, the main source. So there are some more pressure units. There is something called as bar. Where is that bar? So 1 bar equal to 10 raised to 5 what? Pascal, right? Okay, so it is 10 raised to 5 pascals or Newton per meter square. Then you have 1 torr. How much is 1 torr? 1 millimeter of air. You understood? So liquid level actually exerts pressure. Okay, so if you take just 1 millimeter of mercury, whatever pressure is exerted by 1 millimeter of mercury level, that is called 1 torr. So in pharmaceutical industries and all it is used, right, for medicine purposes. Okay, so this is it. So these are the 3 or 4 popular units of pressure. Give me a minute, I'll get my glasses.
अच्छा पढ़ा है उसका मुझे ये पढ़ने का मन नहीं
Yes, what's the crisis? Somebody was crying. I could get it. What happened? What did you do?
Nothing, sir.
Nothing.
Yeah, right.
The truth will come out. So what we have to do.
No, we were actually confused at what happened to our old.
Even I don't have an answer. So nobody has an idea? Any idea? Actually,
Actually, in last class only in the timetable, we were so we were waiting, we were keeping service down. But then she said that no, she doesn't know anything about it.
Today we are biology. Today we were chemistry and biology. So half of it doesn't happen. Exactly, that's the reason.
half of what?
Half of it doesn't have book on it. Because
We thought it's a different class today.
no, because it was supposed to be chemistry and bio today, but then at 4:14 we get announced that there is a replaced physics, and at 4 o'clock we were at magic practice session. Yes.
So I was incubated today morning, like some faculty had emergency, I was told. That's how I am. So it is as much surprise as you are. So let's. Okay. So what is it? Am I going to continue?
No,
No.
we have no idea.
Let's wait for the next one. It's all right. So don't worry. I mean, it is that. Okay. So any issues so far? Is it okay? Right. So what does pressure depends on? So pressure depends on factors.
Pressure depends on the thrust and weight.
Pressure depends on, right? So thrust and area. E is directly proportional to thrust. E is inversely proportional to area. Right? So how can we increase pressure?
To increase pressure, we either have to increase the thrust or decrease the area.
Okay? So it's a no-brainer. So anything on which pressure depends directly, you increase that, pressure will increase. Or decrease area, because it is inversely proportional to it. So if area decreases, pressure will increase, right? So yeah. So what are the examples? So if you have to hammer a nail in the wall, so why nails are made sharp?
So that
So that
because
they
it has
penetrate
less
into the wall
Correct, easily,
easily.
right? So if it is flat, let's say it doesn't have a sharp,
It will make a crack in the wall.
right? I mean, it will be very difficult.
yes.
you
For
have
it
to apply more pressure, like more
more
thrust.
trust, yeah. Then to whether we will succeed or not, right? So nail,
The surface area will also increase.
yes. So nails generally have very pointed front, right? So when it is hammered from the top, it easily pierces into the wall or wood, whatever. Nails have very sharp front. and the head is thick. So this is also when girls wear high heels. Girls wear high heels or ladies, whatever. So this will exert a lot of pressure. Okay, push over here.
So also like.
Because of the small area, right? Whereas our shoes has flat sole. So even though our weight might be more,
Hard to walk in.
Huh?
That's why it's hard to walk in.
hard to walk in because there is stability issue. You're not getting balanced. So it's like you have more, if you have more surface area, like your balance, there is a bigger area to support you, right? But it's a very small area which is supporting your weight. So there is a bigger chance of getting disbalance. Right? So even if a boy or a man having more weight, right? If the sole is flat, right? So like it will be convenient for him to. Is it okay? And the pressure exerted by well maybe less. Is it clear why it is so? Because we have more area. More area means less pressure. Is it clear?
Practical example, this could be, for example, when you go to the beach, if you're lying.
Yeah. So body has a surface area almost 1 meter when you're lying.
Exactly.
Full is 2 meters.
When
So
we
when you're-
stand, we are.
You sink in the sand.
Exactly, that's because.
So everybody got this restriction. So she has done the course in the, so you better like go slow a bit. So are you getting what she's saying? So when you're walking on sand, right? So your legs would sink in sand. Okay, but like I can walk freely on this hard surface, right? But I'm walking on sand. That time I'll also sink in sand, right? Why it is so? Because so why do we sink in sand? Let's go back to course. This is a hard surface, right? And this is a sand. So when you stand here, you're able to walk easily. But when you're standing on the sand, what happens? Why do you sink inside?
Because
Why am I not sinking on the floor?
Because it's hard.
So
sand is granular and
what is holding this sand?
and
Muscles. I'm holding it, right? Muscle. What happens? What happens?
It really
What happens?
goes down.
Why it is not going down below the head?
It's the space.
because hand is exerting.
Yeah, and is exerting force, right? So you must have learned in that chapter that motion is in the direction of net force. Wherever there is excess force, only then the motion is in. So right now, is there any force acting
Yes.
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 in this direction?
Both is and the direction.
So it is acting in both directions, right?
Yes.
So what is the net force acting?
Hand is also active.
Zero. So the resultant force will decide which way the body will move. Okay. So the upward reaction, it has a hand is giving what? Reaction. And what is the downward force? It's weight. The weight due to gravity, right? So force exerted by gravity is called weight. Mass is same. So one force is weight, the other force is reaction. And both are equal and opposite. So they are cancelling. So net force on the pen.
But if it increases, then it will go up.
Yes. So now what happens on the sand? This ground is able to give me reaction which is equal to my weight. The sandy surface doesn't. So you'll keep on sinking till you find hard surface. So sand is like puffy, little above. Right? But when you go inside, those sand granules are tightly packed.
Little bit water.
Huh?
Little bit water.
So whatever. So sand granules are more packed as you go deep into it. So then it is able to exert reaction, which is an equal to the weight. Till then, if you're standing in a soft soil, you keep on going down. That's slow, right? Till you find a rock or hard surface. So your weight has to be balanced by reaction by the ground somewhere. Like Imagine this was very high and now I'm able to hold. So if you catch some heavy object, you'll go down with it possible. Then your muscle will hold it, right? Isn't it? So why did this discussion come?
Because
Because
feet sinking
feet sinking the
in sand from the exam.
Jump of what? So okay. So we lost. Okay, not lost. Something was there where I was going to correlate.
Yeah, because the feet have more pressure on sand than the whole body on sand.
No, lying on the beach. That was it.
Yeah, like
So when you lie on the beach, what happens? So when you're standing, very small area, body weight is not changing. Your mass does not change while you're standing or while you're sleeping. It doesn't distribute. But mass is distributed over a larger area, right? So the pressure is different when you're lying. That's why you're not angry. But when you're standing, pressure is moving, right? Yeah. So we're discussing this practical example. Understood, everyone? Okay. Next one. So now we derive the expression for pressure due to liquid column. Okay. Let's derive the. Let's try to derive this part. Derivation of expression for pressure due to liquid column. So we have a 2-hour class, huh? Back to back.
Yeah.
Okay. When did we start? 6:30.
we have the children. Then
We have a short break at.
yes.
So just remind me, just in case.
The bell rings.
Bell rings.
Yeah, yes.
So this is liquid filled in the beaker. Okay. And from the base, let us say the level of liquid is H. Right. So when you measure the height of the liquid from the top, from the free surface, we call it depth. Right. So this is the depth. And when you measure it from the base, it is called height. Okay. So it's one and the same thing. It's just different ways you are looking at the liquid column. Okay. So this is the liquid column, the height of the depth. Let's find out.
Depth is the
Depth is from top to bottom. That's why I've kept depth above. Top to bottom. This is depth. What is height? This is height. Okay. So our height is measured from the ground, right? So that is height. So just when you're confused between depth and height, it is down up. Okay. And top to bottom is clear. So we want to calculate what is the pressure due to this liquid column. Of this side. So how do we calculate? Pressure is thrust upon area. Thrust. 1/8. We know this. So where is the liquid column? So imagine a small cylinder, imaginary cylinder. Okay. We are imagining a small cylinder, right? So let's say the area is A. Right? What is A? Area. Area of cross section of the cylinder. That is the height. So here also it will be A only, right? And let us say its weight is, what is the weight? Weight of liquid column. Let weight of liquid column liquid column is equal to mg. So as you know, that if mass m is the mass of this liquid column, then its weight would be mg, which is nothing but thrust. Weight is thrust, right? So this is equal to weight of liquid column divided by area of base of liquid column. So what I explained in the diagram, I just written it in words. You have written on the right side?
Yes, yes.
This part. So this is mg upon A. Right? So this is the area. This is also A. This is an imaginary cylinder. Okay. Now, what is mass in terms of volume and density? But density is equal to mass upon volume. You know this formula?
Yes.
That is, the density is represented as rho. Correct? Rho. So what is M? Therefore, L is equal to V into rho. And what is volume? Area into height. So this is equal to AH. Since volume equal to area of base into height of cylinder. Okay, so we'll substitute this value of m over here. Let's call this as q. Substitute one. What do we get? T is equal to m is a h o 3 upon a. A cancel. H O. This, what is amusing you? What is so amusing? Huh? I didn't. This is full water. Now, suppose in this bottle, right? You can see full water, right? From outside. Can you see this? Now within this, I'm imagining a cylinder. Now this is like curvy, but a cylinder is something like this. Yes. Got it? So this level, let us say this this could have been like this kind of a river, right? Narrow at the bottom and wider at the top. So the shape of the vessel does not matter. What matters is only the height. Because if you look, it only depends on the density, the depth, and the gravity at the place. So at everywhere, at the bottom, right? Everywhere, pressure will be same. Okay, it will be same. So it will be same pressure everywhere. Because it is depending only on the height of this water column. That's all, vertical. That's why we have imagined a cylinder. There could be more cylinders like this. So this water has no bearing on pressure here. It's only the top, the height. Okay. So we'll discuss this in more detail. First, you write this. Okay. Yeah, I'm just right. So, pressure of pressure due to liquid column depends on. You're able to see this? Pressure due to liquid column. You can see there. Yes. Depends on height, not height, depth of the liquid. So, okay, let me write about depth or height of liquid. Column. Don't forget to mention column. Density of the liquid. And acceleration due to gravity at the place. Due to gravity at the place. Complete? Okay, so let's discuss this. Now, if I replace this liquid with mercury, let's say this is water. So, what changes? I keep the height same.
The volume will increase. So that
Volume will increase. Kaise?
question.
I replace this liquid with mercury.
The density.
Density will change. And will it increase or decrease? What is the density of mercury? Any idea? So you have to remember density of two substances. Density of water is 1000 kg per meter cube. So which is like 10 to the power 3 kg per meter. And density of mercury is 13.6 into 10 raised to 3 kg per meter cube. So it is almost 13.6 times more than water. Density of mercury is 13.6 times more than water. So if this reservoir or vessel was filled with mercury, okay, it will exert 13.6 times more pressure than the pressure exerted by water. Okay, so you have to keep this thing in mind. So if height is fixed, change of density will increase pressure. If density is fixed, change in the depth of the liquid, that will alter the pressure. Increase will increase, decrease will decrease. And everything is directly proportional. Okay. Are we good till here?
Yeah.
Good. So what are the things on which pressure in a liquid does not depend on? It does not depend on shape and size of the vessel and area of the surface on which it acts. Right? So like I said, so whatever is the pressure at this point, right? Same is the pressure at any point at that level. Got it? For example, let us say if these are the points at the same level, right? Will the pressure be same or different? P1, P2, P3. Will it be same or different at the same level? Huh? It will be different, right? Why? Who said different? And what did you say? क्यों कुछ बोलो बोलो P1, P2, P3 में प्रेशर सेम होगा कि अलग होगा?
Same.
क्या कुछ डाउट है? What does pressure depends on? तो हाइट P1, P2, P3 का हाइट सेम है कि अलग है? सेम है तो प्रेशर सेम होना चाहिए. तो इसमें क्या रट्टा थोड़ी मारना है? This is what we are trying to understand, right? So above P1, P2, P3, the height is same, na? Height मतलब depth of the water is same. So this much water, right, above P1, P2, P3 will exert same pressure at that level. Right? So this is the learning, right? What is the learning? Can I erase this part?
Yes.
Yes. So let's take it as notes. Liquid exerts same pressure at points at same level. Right? Like in this case, P1, P2, P3 will experience same pressure. Where is the pressure maximum? Huh? Where is the pressure maximum? Hold it. Huh? Let others give a chance. I'll come to you. Huh? Just hold your. Where is the pressure maximum? In the middle, it will be maximum. Why? Or at the bottom. Why not only at the bottom? At the bottom. Because H is maximum, na? At the bottom. ठीक है ना? So, is that correct? Yes. Pressure is
Because
Yeah.
the depth is maximum, na?
Yes,
So
the
pressure will
pressure
be maximum at the bottom.
Yeah, the pressure is maximum at the bottom because it's bearing the weight of all the liquid.
Full liquid.
Full
Yes.
liquid on top.
Correct.
That's the reason it has a lot of
Exactly.
pressure.
So
because
is
there's
every-
more of thrust.
क्या बोल रहे हैं? Pressure is maximum at the bottom. क्या चीज कितना है? क्यों पेश खत्म हो गया?
हाँ,
बोर हो गया?
yeah.
भाई अभी और 1 घंटा है. पूरा चैप्टर पढ़ना है, पूरा फिजिक्स पढ़ना है. Today I think today it is too late. You don't have 2 lectures different. You don't talk.
Once we have.
Acha, this is your first lecture today. क्यों बोर हो गया यार? मजा नहीं आ रहा है यार? प्रेशर के बारे में पढ़ो, so that you'll be able to deal with pressure better in life and elsewhere. Okay, student life. Okay. Question: where is pressure minimum?
At the top.
At the top. Right. Is pressure zero at the top? Is minimum at the free surface. How much is that pressure? Up.
No, sir. No.
Admit.
No, sir. But no.
Antara वाले. Shall we admit her and tell her that today max law? Okay, fine. Okay, pressure is minimum at the free surface. That means here. Okay. That is how much is the pressure? And it is equal to what pressure is there at the free surface? Why did you shift behind it? Got bored अचानक. AC बंद तो नहीं करना है? बंद करना है? कर दो. कैसे? This one, down. वो ही बंद करना है.
The eyes closed.
ठीक है. Manage without AC for some time. We'll switch on the fan in some time. Okay, in some time. Pressure is minimum at the free surface and it is equal to which pressure is there at the free surface?
Atmospheric.
Yes, देखा बोल रहा था बोर हो रहा है. It is atmospheric pressure. Atmospheric pressure. समझ आया? और वो कितना है? कितना होता है?
9 point.
क्या ले रहा हूँ? Atmospheric pressure. 1 atm, right?
Yes.
1 atm. Okay, that is, and we call it P0. Atmospheric pressure को कैसे लिखते हैं? Outside pressure, outside the liquid, PO is 1 atm. ठीक है? So what is the total pressure? Now see, there's a difference. H rho G is pressure only due to liquid column. Okay? H rho is pressure due to liquid column. So what is the total pressure here? H rho G plus P0. Got it? So both total pressure. These are the things which will be helpful in solving dividends. Total pressure E is equal to H rho G plus P0. Physics में बोर होने का कोई स्कोप नहीं है. It's very exciting. Huh? What's up? Physics में surrounding की
Yes.
means giving boring yellow.
No, well, I mean, those are right.
Both.
But I'm getting
Listen,
it.
listen. Don't be lazy, okay?
What I meant to say is physics is all about what's in our surroundings while the standing by the topic. Yeah.
What?
That's all.
Physics is all about comfort of life. Mobile, television, internet, aeroplane.
It's basically the study of our surroundings. Right?
It's about everything. Electricity. Can you live without electricity?
Exactly. So it's surrounding.
Yeah, I mean, physics, everything comes under physics. Okay, so it cannot be boring. I mean, it will help you understand कुछ अलग ही चल रहा है क्या हो गया yeah she is saying something whispering and why can't we hear that if it is interesting we should all be why are we denied that opportunity okay if there is interesting stop me sir this is what I want to do what is it nothing okay so first of all it is not boring so don't be bored okay if it is becoming boring stop me it will change the topic till you huh? Huh? Change the topic अच्छा नहीं कैसे नहीं कर सकते
Majority is not so.
सर चालू कीजिए सर 2 मिनट
तो हो जाएगा ना 2 मिनट क्या बात
ब्रेक है
ले लेंगे ब्रेक उसमें क्या okay so is this clear
yes
so what is the learning I mean the total pressure is always sum of atmospheric pressure and pressure due to fluid ठीक है so far so good the next topic is I think we'll start after the break only let's see what else
Hydraulic.
Pascal's law next is Pascal's law right acha one very important characteristic I missed hang on just physics is all about comfort but you should be able to take discomfort out pressure is a scalar quantity okay very important for you what is pressure pressure is a scalar quantity exactly yeah. So this is the fallacy right because it is just so area is also a vector which you'll discover in higher classes
Exactly.
so vector by vector it gives you
Pressure is scalar quantity.
exactly good question
Thank you, sir.
yeah so at this point okay see pressure at this point liquid flows right let us say here if this wall was not here
in some direction
listen if this wall was not here liquid will flow here right so liquid is exerting pressure on the wall also so it is exerting pressure in this direction it is exerting pressure above below everywhere okay liquid exerts pressure in all directions at that point and equally got it so then which direction what is the direction of pressure is it fixed no so unless it is fixed well defined direction it is not a vector quantity a vector quantity has a well defined magnitude and direction at every point but it is not well defined it is same in all directions right that's why pressure is a scalar quantity okay so since I am now entering into break time it acts in all directions
reason for being a scalar quantity
yes because it doesn't have a fixed direction right
yes
it acts in all directions in at any point inside the liquid. Okay, so 5-minute break begins.
How come the area is
11. Yeah, I'm not this to this.
It's hard.
Yes.
Concept भी पकड़ अरे concept की सारी मैंने तो ये रखते हैं कोई ना अच्छी बात है करंट That's not having जा रहे हाथ मेरे This was not the there are साइंटिस्ट का नाम है जंजीरों का डायरेक्शन है हॉलर मांगना अरे नहीं बहुत अच्छा है प्लीज बहुत बहुत अच्छा है जंजीरों का नाइस कौन है उनका नेटवर्क पता नहीं ये वाला बट बायो के सर हमारे घर तो बता रहे हैं इंग्लिश के सर को हाँ कि हम कैसे सही बच्चा है संस्कारों के साथ ही खड़े हुए हैं तेरे बारे में बता क्या सेहत तेरे साक्षर बोल रही है क्या तू है नहीं यू नो इंस्पायर यू तो इतना गालियां देता है ना बेटा संस्कारी है मुझे भी मारना चाहिए वही तो Oh, good boys. These were a Dukala के संस्कारी boys हैं। उसमें आई होगी वो। देख मेरा बॉयफ्रेंड ने नंबर दिया होगा। वो नहीं सर actually because कल मेरे को तो यूजुअली एकदम से डिफरेंस दिखा नहीं। मेरे को तो पहले डॉक्टर कर दे। You don't have that. बॉडी तो बॉडी बोलते हैं क्या बॉडी चार गूगल पे
Is everybody in?
So,
That's what. So she is inside, right? So it's okay.
pizza without bomb. I'll stop you. It's happening. It's cost to try. Yeah, cost to try. How about now? We were searching my area as a vendor area.
Yes,
So everybody open your books, page number 85.
No books.
अच्छा books नहीं लाए हो क्या?
No. So many bad.
Let's discuss about there's something called as laws of liquid pressure. Okay.
Yeah.
I'll just read these laws, and it should be easy to understand because I've explained everything. So following are the 5 laws of liquid pressure. What are they? Inside the liquid, pressure increases with the increasing depth from its free surface. So any issue in understanding that?
No.
So as the depth is increased, the pressure will increase because where is the maximum pressure? bottom. There is the minimum upward. So as you go down, pressure increases, right? Second is, in a stationary liquid, pressure is same at all points on a horizontal plane. So I explained this also. Like at one level or at one plane, right? Pressure will be same at every point. So this is the second law. In a stationary liquid means any liquid in a glass, it's not moving like a flowing liquid in a river, okay? That is a moving liquid, but this is a stationary liquid, right? Contained in a container. This is a stationary liquid. Pressure is same in all directions about a point inside a liquid, right? So if this is the point, it is same in all directions, right? That's why it doesn't have a fixed direction. Now you want the AC to be switched on?
Yes, sir.
Yes, sir.
Or fan?
No.
Same side.
This one, right? Left one.
Yes.
So that was the third law, that pressure is same in all directions, right? What was that? Okay. Fourth, pressure at same depth is different in different liquids. That is also clear. Why?
Because of the density.
Difference, yes. Because of the, whenever you change the liquid, the density changes. You will read it there. चप्पल उतार के बैठो. Okay, so pressure is same. Pressure at same depth is different in different liquids because when you change the liquid, its density changes, right? So either height changes or density changes, pressure will be different. Right? Liquid seeks its own level.
If there are 3 test tubes of different shape or something, and if you pour water in it, water will be in the same level. It will not be reacted with more than one, and it will be less than one. It will be interconnected.
If it is interconnected, then okay. What it means is
It
liquid.
has the ability to do this.
Yeah, liquid seeks its own level, meaning this. Look, suppose you have a test tube, which you have liquid filled. Right? This is the level of failure. Now you tilt it like that. Right? Its level will be same. Okay, right?
Yes.
I mean, it will be horizontal all the time. What do you say? It will always be horizontal. This is now not horizontal. The opening of the test tube. So when you tilt the liquid, the top surface will always be horizontal. It won't be like liquid level will not be like this. Here it is making 90 degrees, right?
Yes.
But now it is not 90 degrees. So it seeks its own level. Okay, because everywhere the pressure has to be same, right? It is only possible. Yeah, what happened? Again, something interesting you found? Yeah, she's like giggling since the beginning of the garden. Drawing must be. Understand the principle. Principle is, why is it seeking? What we're learning here? Liquid is its own level. That is the fifth law, right? Sixth?
Yes.
It was points, law are different. ये points note दिया था. No, sir.
This is the fifth only. I mean, these boys are.
Sir, he is looking at the notes. Yes.
Notes is different. We are discussing about laws of liquid pressure. So ये law भी मतलब time pass law है. I've already explained. Okay. So when you're reading, if you understand. Question I mean, state the second or third law of liquid pressure. So समझ में आना चाहिए कि we've already covered. So the pressures are same now everywhere. is this pressure? See, the difference will come when there is a difference in the pressure. But there is no difference in the pressure. That's why it has to be same. Got it? That is all. Clear? Anybody has any other question on the laws of liquid pressure? No. No. Okay. So if you have, you ask me in the next class. Right? Now, some consequences of liquid pressure. So, pressure at a certain depth in sea water is more than at the same depth in river. Suppose you swim,
Can you repeat, sir?
you take a dive in sea water, say at 10 meters below the free surface, and you take a dive in river water 10 meters below the surface. Where will pressure be more? In sea water?
Sea water.
Why?
Because currents are
Very short current.
and
Deep.
short decreases the density.
Depth is same.
Short decreases the
Density. Sea water density is higher than current. So, sea water density is higher than river water, fresh water. Is that clear?
Little bit less.
Huh?
It has less or
Chemical property नहीं. We are dealing with height and density. और कुछ बात नहीं करेंगे. ठीक है?
yes.
So at the same height or same depth, right? The density of seawater is more than fresh water. That is why it will be. Is that clear?
Yes.
Then wall of dam is made thicker at the bottom.
Because pressure is more at bottom.
Yes. Okay. See this. So now it is not very difficult to. Why the wall thickness is more at the bottom? Because pressure is maximum at the bottom. That's why wall is made. Dam water is made thicker at the bottom. Is that clear?
Yes.
Water supply tank is placed high in our housing societies,
The pressure comes properly.
so that we get good pressure. So water flows with more pressure, right? Otherwise, अगर तुमको 5 मिनट में नहाना है तो तुम 20 मिनट लगा दोगे, आ रहा है धीरे-धीरे. So ठीक है. So with pressure, smoke will be removed fast. Diver's suite, right? So diver's suite or suit, what do we call it? Suite? Swimmers, you dive. So suit, okay? So is it called suit or suite?
Sweet मतलब
Suite नहीं यार, SWE.
वही
SUIT, right? So
वही
this, it's a swimming gear that you.
Yes.
So it is made up of cast aluminum or reinforced plastic, glass reinforced plastic. So it's not a cloth. It is not made up of cloth, right? It is made up of glass. Yes, glass reinforced plastic, so that you can go till more depth.
Yeah.
Otherwise, your body may be crushed due to the high pressure. Got it? So just to protect you, it's a protective gear, right? That's diver's suit or suite, whatever. Size of gas bubble inside water. Where will be the bubble size more?
underwater.
More.
On the surface.
On the
less
surface.
pressure acting.
Yes. So a bubble, air bubble at the bottom will be of smaller size. As it comes up, size increases because pressure reduces on it. Bottom में maximum pressure होता है ना चारों तरफ से, right? So as the bubble comes up, its size will become bigger. Okay. So these are all common sense consequences, and why it happens, we've already learned why it happens. Is that clear? Next is transmission of pressure in liquids. So next is Pascal's law. So make a note of these two topics, laws of pressure. So there are 5 laws that we have discussed. Yes. Okay, so you can do it yourself, right? We've already discussed it. Then consequence of pressure. Oh, you understand. So if there is a question, then you answer. You will be able to answer, I'm sure. Right? Next topic was consequences of liquid pressure. This also we discussed. Since you're following the book, just mention this so that you are aware that we have already completed it, right? So all the dam wall and all that, not dam walls. The more thickness of the bottom of the dam wall. Dam. All right. Next is Pascal's law. These laws were covered in school.
No.
Sir, this is
Hey,
We have the second chapter, we have only one chapter.
in our,
For the syllabus.
these topics were discussed like all these
in
things.
our, we have completed the portion in one time.
Is it?
So then.
Yeah, what?
Different.
Sir, इनका 8 chapter का हो गया.
So why do they do this? So ninth में क्या पढ़ा?
Ninth grade, although they start in 10th house, starting 10th grade, we have less pressure.
Sir, very much ahead of time. Huh?
Encourage not in course.
Next is transmission. So transmission of pressure, which is basically called by Pascal's law. So what is Pascal's law?
Pressure is equal at all points.
That is, that too you know, that is laws of pressure. But what is Pascal's law? Transmission. It's about transmission. See, now let us do an experiment. Okay. So हमारे पास this is a glass.
Pressure travels to the particles.
Right. Hold it. So articulation, it's about how to articulate the answer. Okay. So let us say there are some. So we have different. Why what?
You laugh it.
Let them laugh.
सर गाना दबा के ना हम तो बैठे आ जाएंगे.
गला दबा के कुछ नहीं. अरे यार पता ना एक बार फिर से बहुत जल्दी पक जाते हैं ऐसे पकड़ेगा नहीं.
सर आपने कहा सर मुंह बंद कर रहा है इसके साथ.
किसने वो बंद करने का हिम्मत किया? कौन वो बंद कर रहा है तुम्हारा? कोई और नहीं किया? हाँ? अच्छा थोड़ी. अच्छा ये this is a special type of a flask, ठीक है? And there is water filled in it. So ये level तक there is water. Everywhere same level, ठीक है? Round. So liquid seeks its own level, right?
The level is same.
Level is same and it is matching the top of the vessel. You things. ठीक है समझ जाओ. Now this dots means it is a filled in. Now what we are doing is. So is this a नहीं बुक में दिया हुआ है. अगर बनाना है तो तुम्हें बहुत दिक्कत हो जाएगी नहीं.
So बना भी दिया.
अरे बनाओ यार लेजी क्यों? बनाओ इसमें. क्या हो?
My rough time. Sir.
How much time did it take? I am drawing in front of you, right? Not even a minute. Yeah, it's okay.
Sir, it's very smooth. Not proper.
देखो, it's all straight line and curve. That's it. How many? 1, 2, 3, 4, 5, 6 straight lines, 7, 8, right? That is all.
It's pretty good.
ठीक है. So what you don't have to miss is The level should be same.
Right.
Only then you'll understand the law. Okay. Now see what we are doing. So initially there is a small piston which is fitted here. Everybody understand what is piston?
Okay, sir, bike.
So piston is like
Sir, bike.
इंजेक्शन सबको लगा ना कोरोना
Yes.
किसको नहीं लगा क्यों नहीं लगाया you are immune to this virus okay ठीक है चलो so in injection you have a plunger right
Yes.
so when you press the plunger this piston moves down and that is what like it injects the solution in the body right yeah exactly. So what is being done is now pressure is applied. So there is a head. Let's say now pressure is applied here. Some pressure is applied. Okay. So what will happen? It will, let us say it comes here. So क्या करेगा? It will
Start falling.
it will press the liquid. Okay, so there is no more liquid here because it has come down, right? This is the old position. Now this is the new position. Okay. Okay. So what will happen? The liquid will come out. So you will observe that this liquid starts coming out from the other side.
And मतलब pressure है ना वो.
Pressure apply किया तभी तो. So, but then what is the height? Height हर जगह पे same ही मिलती है. मतलब this is the height we are getting.
पर वो bike से बाहर इसलिए pressure लगाया.
ये देखो ये जो height है ना this height जो jet flow हो रहा है that jet is at the same height everywhere. So what does this mean? This so this pressure, okay, same pressure is transmitted at every level. See here this level is different. Let's say this is 1, this is 2, this is 3. Okay, you had earlier situation you had pressure P1 over here. Here you had P2. Okay, here you had P3, right? Which pressure was greatest in a stationary liquid? P3 was greatest. Now additional pressure P was applied, right? And we are getting same height everywhere, which means the pressure increased at every level was by P only. Got it?
Yes.
So same pressure which was exerted is transmitted at every point in the stationary liquid. जो भी external pressure लगाया हमने. That is why the difference is maintained. There is a pressure difference between here and here, right? Due to the depth. So how will that pressure difference be maintained? Only when the same pressure is transmitted everywhere. What was the difference between P1 and P2? P2 minus P1. That was the difference, no?
Yes.
What? Now when this additional pressure is applied, how we will get the same difference? Because if it was P2 plus P minus P1 plus P, only then we will get P2 minus P1. Isn't it?
Yes.
Isn't it? Yeah. So this is Pascal's law.
Isn't this like common sense?
Hmm?
Isn't this like common sense?
Yeah, but everybody has common sense, but it's hard to realize.
Right. If you have high pressure on a liquid, then you're forcing the molecules of the liquid to come
Together.
as
Yes.
in forcing. So because of
But
the
this
fluid,
liquid is incompressible. It's not compressible.
yeah, we're not compressing. Basically, when you have high pressure, you're forcing the molecule to hit another molecule,
No, but
transmit the pressure.
suppose you're familiar zoom in, zoom out, right? So what happens when we zoom in? It magnifies. When we zoom out, it squeezes, right? So when pressure is applied on us from all sides, I will be converted in my miniature version. Isn't it? So if my density will increase, that's possible. But here we are assuming that liquid is incompressible. So if it is incompressible, so when I'm trying to increase the pressure, it will come out from somewhere. Wherever it finds the opening, it will come out. Right?
The pressure travels.
Yeah. The thing is, you're saying it's common, is it not common sense, right? Yes, it is common sense. But it will make sense when we put it on paper.
It makes sense.
See, it's like, you know, everything is in the head, but how the teacher knows,
Have to give guidance.
right now? So for that we have Pascal's law. See, everything is in nature is known to nature. We are researching it, rediscovering it. Okay, for us, for our benefit. Nature knows its laws, and that's why it is governing the whole universe. But how that universe is functioning, we are trying to pick that. Right? So Mr. Pascal observed it. Before him, everybody observed, but nobody wrote it on the piece of paper, right? So this is what is Pascal's law. What is it? Whenever so that we can study and pass and go to intense standards. Whenever pressure is applied on a stationary liquid, so whenever I say stationary liquid means you have to understand it is contained in some container, right? So is it written stationary liquid or confined liquid? Okay, I didn't do it. Confined liquid. Have you understood what is the meaning of confined? It is kept in a container. Yeah. A confined liquid. Then it is equally transmitted at all points in the liquid undiminished. Now, whatever I explained, the same thing I have written it in words. So this is called Pascal's. Pascal's. Some insight. Liar.
You know, when we just put this to do this to
He is
apply.
trying to figure out the class of physics,
Yeah, like
how,
when
how
we-
she flies. We'll let her know.
Because when you do this to apply, it automatically moves away, right? But it gets scared. But
It is scared
this
for-
apply was so arrogant.
Is it?
Yeah, that it had no effect. I could literally just.
Okay, hang on.
It's had no effect.
Give us some fun time, okay? Let her hop on everybody's head.
Hey, my house.
It was great, huh? You're after your poor flies life. Okay, are we good with Pascal's law?
Please find it.
Is she? Yeah, I mean, good observation. She's confined. She's put up with non-friendly people. Okay. You have to ask, right? Come on now focus. You guys just digress. Huh? For change of momentary digression is okay. Okay, not forever. Anybody has difficulty in understanding Pascal's law?
No.
Clear, right? Now let's discuss the,
What is posting of right?
Servos circle.
this is external force.
What is this one more external force?
Even that will be like, let's say, P1
They could
plus
see
P1 there.
and cause it to not.
Whatever is external, but some total will be pass everywhere. Okay, whatever is external, so everywhere it will be passed. Because that's what the law says, right? The words, my words could be little different, but okay, it gives the same, right? It will be passed at every point in the liquid, in all directions, wherever it is. Yeah. ऐसा serious look दिया तो Okay, okay, go ahead. Consequence. Consequences of Pascal's law. So there are a couple of things that you have to learn. Hydraulic things, right? All the hydraulic press or hydraulic jack. And you have hydraulic press and you have hydraulic brakes.
It's that machine kind of thing where you apply pressure to a spot.
We will see how Pascal's law is applied in these machines. So what is hydraulic?
Related to what?
Correct. Liquid.
So hydraulic brake cycle.
When the machines use liquid, when the machines are based on liquid, okay, then we call it hydraulic. When the machines are based on air, both are fluid, using fluid, liquid or air, then we call it pneumatic. Okay, there's a different term for pneumatics, right? Have you heard about pneumatic? The way you said, oh, mujhe laga. No. So pneumatic you will learn in engineering if you take mechanical or something. Okay. Hydraulic is the spelling correct? Just check the spelling.
Right.
Hydraulic, yes. So I told you hydraulic means liquid. Okay. So let us understand with the press or with the jack. So can you give me an example of a hydraulic jack?
Yes.
Have you been to car service station? So it lifts the whole car, right?
Yes.
Who lifts it?
That
Chain. And who is the operator? A person, a human, right? So what he does, he just presses or uses his leg, right?
Yes.
Or when you apply brakes in your car, I mean, you are not drivers, but if your father is driving a car, when he applies brakes, he exerts a very small pressure. But the whole car which is running stops within a small distance. Imagine we had to stop the car with muscular effort. Come in front of the car and do this. What will happen? रुकेगा नहीं ना गिर जाओगे नहीं फिर कभी खड़े नहीं हो पाओगे हाँ you'll be gone forever, right? So now you understand how much powerful this system is. So everywhere, wherever you have these brakes, these are hydraulic brakes, right? So there is a brake fluid in the car, right? Brake fluid सुना होगा? ठीक है? So you'll get to know. Go home and ask. Like साइकिल में ब्रेक फ्लूइड का हाइड्रोलिक ब्रेक आ गया कौन सी साइकिल चलाता है भाई तू हाइड्रोलिक ब्रेक्स it might be a sports bike, right? Hydraulic brake. I have not seen. अच्छा डिस्क ब्रेक है हाँ तो फिर डिस्क ब्रेक में हाइड्रोलिक लगेगा He is right. Of course.
Pressure.
Yeah, it should be incompressible. तुमने ब्रेक लगाया, लिक्विड ही कंप्रेस हो गया, तो प्रेशर कहाँ गया? वो लिक्विड अभी तुमने उसको कंप्रेस किया, that liquid has to press further, right? It has to press the brake shoes. तब वो डिस्क को पकड़ेगा. तुमने कंप्रेस लिक्विड ही कंप्रेस होके क्रिस्टलाइज हो गया. क्या फायदा होता है? So the liquid should be incompressible and it should be able to handle that pressure and transmit it right. ठीक है, समझ आई बात? So brake fluid का density and viscosity, all those things matter. Viscosity अभी आ गया है. So a thicker liquid is more viscous, like a honey or a mercury, right? Is more denser than water.
So, would the pressure be more in water or in mercury? Or in with the same amount of pressure?
So, same amount of the pressure, whether it is applied to water or mercury, he will be passed equally in water as well as in mercury, as long as the liquid is contained. Okay? We are assuming they are both incompressible, right? But for vehicle, you can't fill water. Because there is a specification. So every water will not be able to take that kind of pressure. Because बहुत pressure लगेगा, उसमें water हो सकता है compress हो जाए. Because it produces heat also. It may convert it to steam or something like that. Okay. So there is, every machine has got a specified liquid. Do you fill water in your engine oil? No. There is a specific liquid.
So always more denser.
Not denser. There is a property. It's like it's engineering. Okay, so you'll have to read.
It doesn't
Cover
produce,
that.
it reduces the liquid.
Exactly. So it keeps your engine in shape, right? Lubrication intact. Water डालने के तो water तो गर्म होके उड़ जाएगा. Okay, so you have to have that specific liquid
It has
as
period.
recommended by the manufacturer. You just can't put anything. Okay. Is it clear?
Yes.
So now let us understand. We have time, right?
Yes, sir. Yes.
So let's cover. So कोई भी एक,
25.
any one machine you understand, everything is understood. Okay. Yeah. Right. You have written it, right?
Yes.
Okay. Pascal's law का application. Now look here. So we have. This is a smaller piston. So this is the explanation for how Pascal's law works. So we have two pistons of different cross-sectional areas. Okay. And there are two pistons fitted over here. There is a platform fitted over here.
The radius of the tank.
This is a platform. इसके ऊपर you can have a car or okay. Now these are two pistons. Okay.
The गाड़ी से दो खिड़की उधर में do it like
Car.
एक साइकिल
Four. चार
अच्छा
tires.
क्या करेंगे बिल्कुल बैलेंस
So it has to be too much water.
Forget about car. Pay attention to how Pascal's law is at work. Okay. So this is A1. This is A2. So we have a support staff. Marker there. Blank. Marker नहीं है. हाँ. Okay. So what do you have? You have two pistons, one with a smaller cross-sectional area, one with a large cross-sectional area, right? And it is filled with,
The pressure would be exerted with the same.
so right now, liquid will follow its own level, right?
Instead of applying the pressure on large area, we're applying it on a smaller area. so
Yes.
that's pressure.
Right. So we apply a pressure P1 over here. Let us
सर ये नीचे को ऐड कर रहे हो क्या बना उसका?
Fine.
liquid, hydraulic,
अच्छा liquid.
whatever is recommended for this machine. Okay. So imagine this is some liquid, it's not water. Every manufacturer, right, will decide which liquid and you have to just, so imagine that liquid is filled. So it's a hydraulic system. You don't worry about what liquid it is. Okay. Its only thing is it's not incompressible.
So when it is pushed from that side, that liquid comes in and pumps it.
Yes. So now what is the pressure applied here? P1. So obviously what will happen?
P1.
So here let us say pressure P2 is applied. एक भी नहीं है खुला वो मेरे पेन वापस करो प्लीज इसी से काम चलाएंगे आज हाँ एक ऑर्डर कर देना ठीक है okay so what will be force over here so P1 since P1 is equal to F1 upon A1 thrust upon area right so what is the force and P2 will be, so when you apply pressure over here, right? So here this piston will apply pressure in this direction. And here, same thing will go here. So P2 is equal to now, but you will get a different force, okay? Right? But by Pascal's law, what is the Pascal's law? P1 must be equal to P2. That is F1 upon A1 must be equal to F2 upon A2. So what does this give you? What is F2? A2 by A1 times F1. So is A2 greater than A1?
No.
No.
The area.
Yeah,
Sorry,
A2.
yes. The area. I heard.
Now since A2 is greater than A1, right? So you get a bigger factor, you get a factor greater than 1, right? So this would mean you would get F2 greater than F1. I should write A2 much greater than A1. A2 is much greater than A1, therefore F2 is much greater than F2 is much greater than F1. What is going?
Then nothing, my friend.
Twice ice.
No.
Then?
And
Acha.
then freedom.
So, what is the consequence here? We are applying a small force, right?
For a small force on a
Small pressure. Pressure when we are applying, we are getting a force. F1 is equal to P1A1, right? So since A1 is small, right? F1 will be small, correct? Here, we applied F1 here at the first piston. Okay. Are you with the line with the fly? Okay, come here. We are discussing something.
Yes.
F1 is a small force, and we are getting in return very large force. Okay. So that large force is able to lift the car. Kaise? With the help of Pascal's law. Same pressure. छोटा सा जो pressure हमने यहाँ पे apply किया, वही छोटा pressure is getting converted into a bigger force. Just murdered. Okay. So
I'm moving.
बिल्कुल मार के कर उस बात
is everybody with me?
Yes, sir.
So what is the machine acting as? I think you're overreacting now.
Yes.
You're overreacting.
Just like
So
you were.
the machine is working as force multiplier. I found a good marker. The machine is working as force multiplier. Okay. Is it clear?
Yeah.
So by applying a small pressure, we are getting a larger force. That's why it is a force multiplier. So imagine if this area was, this is 1 meter square and this is 10 meter square. So we'll get
Same question.
10 times the force. F2 will be 10 times. So generally it is, so if I want 100 times or 1000 times, accordingly I will choose a piston area. Got it? If I am applying, if I want my force to be multiplied 10 times, 100 times, 1000 times, accordingly I will design my machine. Okay? So that's up to me. Got it? So any idea what is the weight of a car?
Yes.
800 kg.
A normal hatchback car 1500.
Wow, this guy loves car, right? Okay, so it's generally 1.5 to 2 tons, right? So, okay. Ton is 1000 kg. So, this is the principle of hydraulic motion. What we have discussed here is principle of hydraulic motion. Any questions here?
No.
Easy.
Yeah.
No. So the same principle works in all the things. So now, having understood the principle of hydraulic machine, we will see how this principle works in all the devices, right? Actually, this topic should come here, principle of hydraulic. Okay. And this principle is utilized in all the machines. Is that clear?
Yes.
The force multiplication. Now we'll discuss individual machines function. So this is very important. Everything you write. This everything you should write. Now, we come to then discuss from the book. Okay. These diagrams are little bigger. If there is anything which you have difficulty in understanding, please ask. All good? You?
Yeah.
So nothing is difficult in this chapter. So far. How did what? So like my teacher was a good teacher, I think. And I did not go after flies when he was teaching. But I grasped it better, I think. Just joking, huh? You can play with the flies whenever you want.
Seems boring when you already know the concept and then you're learning it.
I agree, because if they teach you 9th stuff in 8th standard, what are you going to do in 9th, 10th?
Oh. Now we are going to start with the repeats.
Come on, yeah, and this is too much.
And in this,
I think it's very harsh on student to, or maybe your syllabus is too much. Yeah, maybe the syllabus also is more no, for ICSE. Because- So maybe because he used to have large portion, no? Now you are running with reduced portion of syllabus, right? Is it full portion from this year?
Yes.
Are you sure?
Yes.
No, check your.
Yes.
It is full portion of the published syllabus, and I know there was different portion previously.
It's not reduced.
Got it? So, see, every year ICSE publishes new books. Every year the book printed is different. It carries different portion. That is why you can't, if you have any senior, you can't use his book. Like when we used to study in CBSE, same book was used for at least 10 years, right? But not with ICSE. Every year they change the syllabus and they print new books. So for business reasons, like, so that every year there will be sale purchase going on, right? It's because of that. So the syllabus given for printed in your book is actually less than the previous year syllabus. That's what I'm saying. Right? Shall we discuss the machines? So the first one is in the book is hydraulic press, right? So where are we going to use the hydraulic press? Now look here. This is a bigger piston, bigger cylinder, right? So what is cylinder and what is piston? This is a cylinder, the beaker, the one which contains the liquid. And on top of it, you have a piston. Okay, piston is something which moves up and down depending upon. So there is a plunger and this disc, circular disc. Yeah, so this is a circular disc which almost touches both the surfaces, right? So there is no gap. So when you press, then the liquid will be pressed. Okay, and likewise, whatever pressure is generated here, it will be transmitted because of Pascal's law. But the same pressure will result in a different force due to the difference in the area, right? Because pressure is force is A2 by A1 into F. So more area will give you bigger force. Okay, understood. So now look at this machine. So you have a bigger cylinder and a smaller cylinder.
It's not at all visible.
It is not at all visible. Is it visible now?
Yes.
Okay. So handle now. So here I applied the pressure directly in case of while you are learning the principle of hydraulic printing. Now you have this mechanism, like in villages we used to have water
Hand pump.
mechanical hand pump, right? So like that. So you apply, when you press it down, this piston will be pushed down, right? When you pull it up, so the water, okay, from the lower beaker, water name, the liquid will be filled in this. Okay, and then there is a valve. Valve. You know what is valve?
Yes.
It allows liquid only in one direction. So it allows liquid flow only from bottom to top. So once the liquid is filled, now when you press it, this valve is closed. Hello? Where are you? Don't draw the diagram. Look here. Look at the explanation. Come on. When this is lifted up, the liquid is filled in. Right. When you press it down, this valve closes. This opening is closed down. So then the liquid has to pass through this into the next cylinder. Got it? So here also there is a valve. So once you press it, now the liquid will fill in here. And that will lift this piston. Okay. So this is, now here is the cotton bale which you are trying to press. Okay. So in medical, when you go to buy cotton, you get a pressed cotton, right? It is compressed. So this is how it is. Like papers, etc. Right? You want to press mustard seeds, oil will come out of it. Got it? So anything which has to be pressed is kept here. And now you apply a small pressure, and a large pressure will crush it. Got it? So there is a frame. Okay. So now once it is pressed, then what do? There is a release valve. You open it, so this liquid will then flow from here. It will get filled in the old reservoir, and this will come down. Now keep some other thing. Again, you lift and press. Okay, this is how it works. Understood? So, where is Pascal's law at work? When you apply the pressure, it is transmitted equally, but it generates large force. So, the machine is acting as force multiplier. It is called force multiplier, right? So, this name of this press is Brahma press. Okay, so we've understood Brahma press. Okay. So, what is the working principle? Pascal's laws. Okay, okay. Yes, next is the hydraulic jack. The hydraulic jack we have already समझ लिया. Okay, here again the same thing. Here's this. Okay, you press it, and then this jack will lift the car. Okay, same. This is the brake mechanism, the hydraulic brake. Now look here. So this is the tire, right? Tire is not shown. What is shown is the braking mechanism. So what you have is there are two pistons. This is the driver. When he presses the brake, look here. This girl is just not moving. Hello. But what movement I am making? My video is not flashing in your book, right? Yeah. Look here. Look here. It will help you understand. Otherwise, later on you are going to struggle. Now look here. When the brake is pressed, right? There is a small piston. With the fluid fill, there are two cylinders, right? So in this cylinder, the liquid is entering in the middle, and there are two parallel pistons. Is it visible? There are two parallel. So when the liquid enters here, once the brake is applied, it will press both the pistons away. And when both the pistons are pressed away, there are brake shoes. These brake shoes will be pressed, and it will just touch the ring. Okay, these shoes are connected by spring. So these shoes will be stretched apart, and therefore the ring will experience friction. So the rolling wheel will not be free; it will stop. It's yeah, you can say that, right? So when you apply this brake, it will stop the wheel after some time.
It has rubber pad.
No, it has metal shoes.
No,
It has
rubber pad.
Not in vehicles. In cycle, it is rubber pad. So vehicle rubber will burn. Because the speeds are yes. In the disc brake, yeah. So it's not rubber pad, not in vehicles. So it will stop the car, right? Once it is stopped, when the brake is released, right? So there is a spring now. Can you see the spring? This spring will again pull the shoes together. So when it pulls it, again it will press the liquid brake. So there are spring action, right? Both in the brake and this brake shoes. So it will resume the original position. Got it? It's not like once the brake is applied, the car stays forever, right? It will be released. Once released, it will resume the original position. So everywhere it is Pascal's law, right? Good. So one topic is finished. Okay. So there is something called as mechanical advantage and velocity ratio, which I think you need not bother. It will be covered in detail in next standard. The first chapter of this, it is in the chapter machines. That's the third chapter of 10th standard. So you need not worry about it, the mechanical advantage and all, right? It is a measure for a force multiplier, load upon effort. So don't worry about it. All right. Any questions in what we discussed today? Can you quickly summarize what did we discuss today? Okay. What was the formula discussed?
Pressure is equals to thrust acting per unit area.
So I follow a practice with all my methods. We will write the formula summary at the end of every topic. Okay, or at the end of every chapter. So that in solving, while solving numericals, you have the ready list of formulas in front of you. So, repeat with me, what was the first formula we did? Yes, first of all, what else?
Pressure is equals to.
Pressure due to liquid column is
Yeah.
H, rho, and G.
Yeah.
What else?
H is high.
So, Pascal's law. What was that? So formulas and laws, everything. At least write the title. What is Pascal's law? It's P1 is equal to P2. Okay. Same pressure is transferred everywhere. And then for force multiplication, what did you write? F2 is equal to A2 upon A1 times F1. So when you apply pressure, it translates into force. What is force? F upon A. Thrust is nothing but force. What is the force? Pressure into area, right? This force is pressure times area. So this is it. Next class. So we'll do numericals in the end after finishing all the topics of this chapter. The next class will begin with atmospheric pressure. And I think there are only two topics in this chapter, right? And now we can discuss about the fly. Where is it gone? What was the color? Black. Is it still there or gone? It's resting. Fly was discussed.
No, it's resting.
It's resting. But I hope not resting. Resting in peace. I hope you also follow your techniques. Because here the time.
और छोटे छोटे बातें चिल्लाते हैं बहुत कॉल कुछ होता है